In this lesson, I will explain to you the concept of conditional probability. So the formula for the conditional probability is probability of A, means you have to find out the probability of A given that B is already occurred. So here we have the condition that the B is already occurred, which is equal to probability of A intersection B divided by probability of B. Keep in mind, you do not have to think what you have to write down in the denominator. Whatever is the condition, if it is C, given that D is given, you have to write down D here. So in this case, generally we have this formula. That is why whatever is the condition, you have to write down in denominator. And in some books, you can see instead of intersection, they use A and B. So both are same. But quickly, I will explain to you the concept of intersection. Suppose we have two sets. In set A, we have 1, 2, 3, and 4. In set B, suppose we have 1, 2, 5, and 6. If someone will ask you what is A intersection B or B intersection A, means whatever is common between these two sets. So see, 1, 1 is here. We have 2 in both sets, but we do not have 3, 4, 5, 6. So these two are same. It means A intersection B or B intersection A or A and B, right? If it says A and B in the book, all are same 1 and 2. Here I will give you example, then we will solve our equation. So this is my universal set. You mean universal set. In universal set, I have one set which is represented by A, because in the formula I have A and B. That is why I am using A and B. There are suppose 30% students belongs to group A or set A who only read their books and then go for their exam, right? And then we have set B. I will do this overlapping. This is B. There are 50% students who practice, means who write or who practice the test or whatever, and then they go for the exam. What is this part mean? This is the intersection part or common part, means A intersection B or A and B. There are 20% students who read and practice or write and then they go for the exam. So this is called the universal or the sample space. Before applying without the condition, this is considered the sample space. But as you know that here we have to apply the condition which is equal to A intersection B. It means we have to calculate this part, we have to calculate this part. In order to find out the probability of A while B is given, we have to find out two probabilities. So now we are going to apply the condition on this diagram. It means we are going to reduce our sample size. This is complete sample size without condition. Now in condition from here to here, because we have to calculate A intersection B, this part, and B this part. So I am just going like this. Now this is my sample space. This part A is not the sample space. We have to find out the probability of A. This part is the sample space after applying condition. So my first part is directly you can apply here, or I will show you one by one. My first numerator is A intersection B, this part. It means there are 20% or 20 students, total is 100, right? Total are 100 students, 20 read and write and then they go for the exam. So output is 0.20. And then for the B, this is our condition, right? So there are 50 students out of 100 who only practice or only write and then go. So this is 0.20, 0.25. Now it is very easy to find the probability of A while B is already occurred. So A intersection B is 0.20 divided by 0.50, which is equal to 0.40 is the probability of event A given that B is already occurred. So I hope the concept of conditional probability is clear. Please practice it, subscribe to my channel, and thanks for watching.